Hello, viewers. Welcome back. 11.2, it's about algebra of matrices. So the first thing we will start here is discussing what you mean by equality of matrices. Now, if you have two matrices, let's say you have matrix A is given by Aij, where I represent the row and J represent the column. So, and you have a matrix B, which is equals to Bij. Now, we said that two matrices can be equal if and only if what? There is a condition that needs to be satisfied. And what is that condition? The first thing is that the two matrices must have the same what? They must have the same dimension. And not just that, and each individual entry must also be the same, right? So for example, now, if you look at example 1, we said find A and B, A, B, C, and D, if these matrices are the same. Now, you can compare because both of them are what? 2 by 2 matrix. This is a 2 by 2. This is also a 2 by 2 matrix. So the first condition is satisfied. It says if they have the same what? Dimension. So these two matrices have the same dimension. Now, does that make them equal? No. For them to be equal, look at this condition. It said Aij must be equals to what? Bij. So for this particular matrix, what is I? We see I can be 1, it can be 2. Also, J can be 1, it can be 2. So it means that each entry must be the same. So for this matrix to be equal, A11 must be equals to what? B11. So what I mean by A11 is the first element in this matrix. So which is just what? A. So A has to be equals to 1. Also B, which is occupying the first row, second column, must be equals to 3, which is also occupying first row, second column. So B must be 3. Then C has to be 5, and D has to be 2. So if these conditions are satisfied, then we say the two matrices are what? Are equal. In summary, two matrices are equal if they have the same dimension. In other words, they have the same order. And the corresponding entries are what? Are equal. So take note of that. We will use it later for some calculation. Now, the next thing here is discussing addition, subtraction, and scalar multiplication of matrices. So if you have two matrices, how do you find the sum? The sum of two matrices. Now, also, look at the condition. Matrix A, matrix B, they must have the same dimension. So before you add two matrices, before you add or before you subtract, you must be sure that the matrices have the same dimension, right? So for addition, what is A plus B? A plus B means that what? You're going to add the corresponding what? The corresponding entries. So we will see an example. Let's see this example now. For example, this is matrix A, and this is matrix B. So the first thing you look at, you see that the dimensions are the same. Matrix A is what? Is 3 by 2. This is also 3 by 2. So you can add. So you see the addition here. How do you add? Just add the corresponding element. You add 2 and 1. So 2 plus 1 will give us 3. Minus 3 plus 1 will give us, minus 3 plus 0 will give us minus 3. 0 plus minus 3 will give us minus 3. 5 and 1 will give us 6. Then 7 and 2 will give us what? So let me just highlight 1 or 2 of it. For example, now 7 plus 2 will give us what? Will give us 9. And what if you look at this, but minus half plus 2 will give us what? Will give us 3/2. So this is continuous. Right? Now, this is how we do addition. Then for subtraction, it's also the same. So subtraction also, all you need to do is to subtract the what? The corresponding. First of all, they have to be the same dimension. So for example, 7 here minus 6 is going to be what? It's going to be 1. Yes? 7 minus 6 is 1. And we will see that what? Minus 3 minus 0 is going to give us what? Minus 3. And this is, and let's have one more. So you see something like 0 and minus 6 is going to give us what? Now you see there is a minus here. So you have minus minus 6. So this will just become plus 6. So this is how you do it. But something interesting here, if you look at C plus A, can we add C and A? No, we cannot add them because C and A do not have the same dimension. So for example, this is C. You can see C is what? C is 2 by 3. So C is 2 by 3, but A is what? 3 by 2. So we cannot add. So that is why we say C plus A is undefined. Why is it undefined? It's undefined because we cannot add matrices with different what? Dimension. Okay. Then finally is what we call the scalar multiplication. Scalar multiplication means you have a matrix, then you multiply that matrix with a number, with a constant. Let's say non-zero constant. When I say non-zero constant, I can say any real number, right? Maybe except 0. So what you see here is, for example, here we have 5a. So in this case, you don't need to care about the 5 is just a number. It's just a real number. So the dimension also will not change. So if you multiply a matrix by a constant, the dimension remains the same. So for example, this is what? This is a 3 by 2. If you, by multiplying by 5 means you multiply each entry. So you multiply each entry by what? By 5. You multiply each entry by 5 and you get this. So the same, you multiply 5 by minus 3, you get minus 15. And you can see you still have a 3 by 3 matrix. Sorry, the same order, not 3 by 3, but 3 by 2. This is 3 by 2. This is still 3 by 2. All right, now the next thing we will talk about is when you multiply, or let's look at some properties before we look at the multiplication of two matrices. So this one, it says that what? Properties of addition and scalar multiplication. So here we're only dealing with addition, and what? Scalar multiplication. If you have matrix A plus B is the same thing as matrix B plus A. So in other words, we can say that matrix addition is what? Is commutative, right? But we know that A minus B is not necessarily going to be B minus A. So we can see that subtraction of matrices is not commutative. So let me add it here. A minus B is not the same thing as what? B minus A, which means that what? Subtraction of matrices is not what? Commutative. commutative. Okay. So, but here we also have associativity. Associativity means A plus B plus C. It's equals to A plus, and this will be B plus what? Plus C. Is that okay? So it means the order is not important. Associativity is okay. So we call it associativity property of matrix addition. Then here is also another property which we can call the associative property of scalar multiplication. So it simply means if you are multiplying a matrix by a scalar, two scalars. So let's say you have a matrix and a matrix A, and you want to find 2 times A, or you have 2A multiplied by 3. This is the same thing as 3 to no, this is the same thing as 2 3A. This is still true. All right, and now you can see the distributive property. The distributive property is what? If you have 2 scalars and then you have a matrix, you can distribute the multiplication over the what? The addition. So these are some properties of addition and scalar multiplication of matrices. Okay. Oh. Okay, so now before we close this, well, let's take something else, which is called multiplication of what? Of matrices. Multiplication of matrices. Now we've talked of addition, we talk of subtraction. You can only add and subtract 2 matrices if they have the same dimension, right? But in the case of multiplication, it's a different ball game. In case of multiplication, let's assume you have matrix A, which is m by n, and you have matrix B, which is n by what? N by k, right? So you see that what? The columns in A and the rows in what? In B, they have to be the same. Look at it. Why is the column in A? The column in A is what? Is n. What is the row in B? Is also what? N. So because they are the same, then this is okay. So it means that what? This is possible. So it means that the product AB is possible. Now, AB is possible, and the dimension, what will be the dimension of AB? The dimension of AB is going to be this one. It's going to be this two, M by what? By K. So AB is going to be M by K. All right. But now let's look at BA. Is BA possible? What is BA? BA now means that's what? The dimension, when I say BA, because look at this, B is N by K. So let me write it. B is N by K. While A is what? Is M by N. So this is not possible, right? This is not possible, and why it's not possible is because of this one here. You see here, the row here is K, and the column here is K, the row here is M. So it's not possible simply because what? Because our K is not equals to M. Right. So let's see specific example on how to do that. Now, how do we multiply? It's very easy. We just need to use what we call the row by column operation. So for example, this is what? This is a 2 by 2 matrix. This is also a 2 by 2 matrix. So it means that this is possible because the column in the first row is the same thing as what? The row in the second row. So in the second matrix. So it means that AB is what? Is possible because this is 2 by 2. This is also 2 by 2. And it means that you have 2 and what? And 2. So AB is possible. And how do you find AB? All you need to do is you do this. This is 1, 3, minus 1, 0. And you put this together. Minus 1, 5, 2, 0, 4, 7. Now, what is be the dimension of AB? Because this is 2 by 2, and this is 2 by, no, sorry, B is what? B is 2 by 3, not 2 by 2, 2 by 3. But it's still possible because this is 2 and this is 2. So it means that the product AB is going to be, remember, it's going to be 2 by what? 2 by 3. So this is going to be a 2 by 3. This is going to be a 2 by 3 matrix. Okay. So how can we get that? Just take this row here and multiply with what? With this column. This will give us our first. So this will be 1 times, let me write it in expanded form. So this will be 1 times minus 1 plus 3 times 0. Then you take the same row, you multiply it with the second column. So this will be 1 times what? 5 plus what? 3 times 4. Then finally, you take this and multiply again with the third column. So this will give us 1 times 2 plus 3 times 7. Okay. Then you do the same for the second row. So we are done with the first row. Now the second row, you take the element in the second row and you do the same. So it's going to be minus 1 times what? Minus 1 plus 0 times 0. Then you take again second row, second column. This will be minus 1 times 5 plus 0 times 4. Then minus 1 times 2 is going to be minus 2. So you have minus 1 times 2. Minus 1 times 2 plus 0 times 7. So this we can write this easily. This is minus 1. So here it's minus 1 plus what? 0. And here it's 5 plus 12. And here it's 2 plus what? Plus 21. And then this is minus 1 times minus 1. This is going to be 1 plus 0. And here it's minus 5 plus 0. And this is minus 2 plus 0. So we will get, if everything is correct, this should be minus 1. It should be 17. This is what? 23. And this is 1 minus 5 and minus 2. So this is the expected matrix. Hmm. So now, okay, now, so you can see that AB, this is matrix AB, and you can see that this is what? This is a 2 by what? 3 matrix. So now let's see matrix BA. BA now, it means you have to write the B first. This is very important. So this is minus 1, 5, 2, 0, 4, 7. And then this one is what? It's 1, 3, minus 1, 0. Now, don't just start directly. First of all, you need to check. Does this make sense? Don't forget that this is 2 by what? This is B. B is where is our matrix B? This is our matrix B. It's 2 by 3. Then you want to multiply it with another matrix, which is 2 by what? 2. So you will have that the column here is 3, but the row here is what? Is 2. So it means that what? This is impossible. So all you need to write is that what? BA is not possible. And this is since what? 3 is not the same thing as what? As 2. And you're done. So here, what is the lesson here? It simply means that what? We can see that AB is not necessarily the same thing as what? B times A. So in other words, we can say that matrix multiplication is not commutative, right? So this is what we are discussing here. So this is telling about the properties of what? Of matrix multiplication. So we have to take note. If you are multiplying a matrix, the order is very important. Whether you are multiplying from the left or you are multiplying from the right is very good. But here, matrix multiplication is still associative. It means if you have 3 matrices, A, B, and C, you can start by multiplying B, C before multiplying with A, or you can multiply A, B first before you multiply with C. It's still the same. But these two are very important. If you want to distribute matrices using distributive law or property, look at this one. If you have A times B, you know, for numbers, if you are dealing with numbers, if I have 2x plus, say, y, right? Let's say 2x plus y. This is the same thing as what? 2x plus what? Plus 2y. Also, if I have x plus y, then I put 2 here. It's still the same thing as 2x plus what? 2y. It doesn't matter where you multiply from the left or from the right. This is true, but only for real numbers. This is not true for matrices. So that is why we have these two property. So for matrix here, when you multiply by the left, it means your multiplication, A is from the left. So it's going to be AB. The A must always remain to the left. So you cannot write BA. No, they are two different things. So it means that if you have A, B plus C, it's not the same thing as what? BA plus what? Even maybe plus, let's say, AC. This is not the same. Because here you have changed AB to BA, which is not always the same. So the A must remain to the left. So you must keep the A to the left. All right. And here also, for the second one, you are multiplying by from the right. So we have to keep the A to the right. So this is actually, we have what we call this. You can say this is what we call the right multiplication, because you are multiplying from the right. And here you can call it left multiplication. because we are multiplying from the left. All right. So let's remove this one. So this in red says when both AB and BA are what are defined, they are not necessarily what equal. So even when both AB and BA make sense, yeah, but they don't have to be the same. So this is just one example here to illustrate that. So if you look at this matrix, this is matrix A, this is matrix B, right? So you can find AB makes sense, BA also makes sense, because if I want to find AB, this is 2 by 2, this is also 2 by 2, and you can see that it is compatible enough. This is 2 column and this is 2 row. So it's fine. So it means we are going to have 2 by 2. Now, if you want to find BA, also, BA is going to be 1, 2, 9 minus 1, this one. So here also, it's going to be 2 by 2, and this is 2 by 2, right? So you see, this is also makes sense because you will have 2 here, 2 here. So this is still good. But when you do the multiplication using what we did just now, the row column, you will discover that what? Your AB is this one. So AB is this matrix. This is matrix AB. Is this. But matrix BA is this one. And you can see they are not the same, right? So that is why we said AB is not equals to BA. In general, they are not the same. So let's just, okay, I think that will be it. In the next video, we'll just look at old exam where we apply all these things that we have discussed. All right, thank you for watching, and look forward for the next video.